Hello learners, welcome to this course on Embedded System Design using AT89C51 microcontroller. So in this tutorial, I will be describing about on how to control an LED using the status of a switch. So LED is a simple two-terminal device which has anode and cathode. So we can connect an anode to a supply and cathode to a ground. It's an optical source which can emit at different wavelengths in red, green, yellow, blue, etc. So here we will be seeing how to control this LED, switch it on or off depending upon the status of your switch. So I will be taking an LED array, connecting it to port 2 of your 89C51 microcontroller, and a switch will be connected to port 1.7 pin. So here I will be using 8 LEDs and I will be using one switch to get connected to your port 1.7. So an important thing to note here is we have 4 ports on the microcontroller: port 0, port 1, port 2, port 3. All are 8-bit ports, and by default this port pins will be configured as an output pins. Since we are using an input device switch, I need to specify, or as a programmer we need to specify that I am going to use this port 1.7 pin as an input pin. Then only we can take the status of the switch. Depending upon the status of the switch, I can control the LED connected to port 2. And another important aspect is this port 2 as an internal pull-up. So by default this port 2 pins will be at logic high. So a logic 0 given to this port 2 pin will make the LED to glow. Same way, port 1.7 pin also by default it will be at logic high. So when I press a switch, a logic 0 should be given as an input to your port 1.7. So here I show a typical circuit where we are using 89C51 microcontroller. So in order for the microcontroller to work, we connect an oscillator circuit. So here I use a crystal of 10 MHz, and in order to produce a stable frequency we use 33 picofarad capacitors. And this oscillator circuit is connected to XTAL1 and XTAL2 pin of your microcontroller. And there is another important circuit which we need to do, which is your reset circuit. So the reset pin is an active high pin. So by default this pin will be at logic 0, since this pin is connected to a ground through a resistor. So whenever I close the switch, there will be a voltage drop across this resistor. So thereby the reset pin will go from 0 to 1 transition. So thereby reset operation will take place. And I have taken a bar graph LED where pin number 1 to 8 represents the anode of the LEDs, pin number 13 to 20 represents the cathode of the LEDs. So anodes I have interconnected and given it to a supply. Cathodes I have connected it to port 2.0 to 2.7. So remember, there is an internal pull-up on this port. So by default this port pins will be at logic high. So by providing logic 0 to the pin will make the LED to glow. So then in order to give an input, I have connected a switch connected to a ground. Other end of the switch is connected to port 1.7. So by default this port 1.7 will be at logic high. Whenever I close the switch, this port 1.7 will go to logic 0. So once my port 1.7 goes to logic 0, I do some functionality in the LEDs. So this is how we interface a LED with a microcontroller and a switch with a microcontroller, and we'll be writing our program in Micro C Pro for AT51 integrated development environment. So after converting this embedded C program into a hexadecimal file, we import that file into the circuit built on a Proteus 8 professional simulator. Then we will try to check the logic. So now let us start building our circuit. So here I show AT89C51 microcontroller, which is connected with the oscillator circuitry and a reset circuitry. A switch is connected to port 1.7 and a bar graph LED is connected to port 2. So a logic 0 to the port 2 pins will make the LED to glow. Logic 1 given to the port 2 pins will be making the LED to be off state. So after building the circuit, we go and write the program in micro C Pro for AT51. All the C programs will have a main function, and the first step is that all the port pins are configured by default as output ports. Since we are connecting a switch to port 1.7 pin, I need to specify it as an input port. So how to specify it as an input port? Just by writing 1 to that port pin will make that pin to be an input port. So I am going to use port 1 is a 8-bit port. In that I am going to use only one pin, that is 7th pin. So in order to use a single pin, we use it like this. Port 1 dot F7 is equal to 1, which makes that port 1 7th pin to be an input pin. Then I initialize an infinite loop using the while loop function. So inside the while loop, I check the status of that port 1 7th pin, whether it is going to 0. If it is going to 0, what I do? I switch on all the LEDs connected to port 2. So remember, logic 0 to port 2 will make the LED to glow. After 1 second, I am going to turn off all the LEDs by providing a value of 0xFF. So this is what happens when the switch is pressed. When the switch is pressed, all the LEDs connected to port 2 will light up for 1 second, and then it will go to off state for 1 second. If the switch is not pressed, then the else part will be executed. If the switch is not pressed, I send a value of 0x55, which means in port 2 I have 0101 0101. So where port 2 7th pin LED will be on state, 6th pin LED will be in off, 5th pin LED will be in on, 4th pin will be off, 3rd pin will be on, 2nd pin will be off, 1st pin will be on, and 0th pin will be off. So this logic gets retained for 1 second, and then I am going to change the logic to 0xAA. So AA represents 10 10 10 10. So I use two conditions. So LED will show a different status when the switch is pressed, and it will show a different status when the switch is not pressed. So after writing this program, we need to convert this program into an hexadecimal file. For that I build the program. So after building the program, we go to the circuit created in Proteus 8 environment, right click on the IC, go to edit properties. I set the oscillator frequency to be 10 MHz and select the hexadecimal file, which is switch_LED. So I import that hexadecimal file onto the IC. So now I want to check whether the program is working properly or not. So press the play button. You can see right now the switch is not pressed. So you can see it is showing a logic of 0x55 and 0xAA. It is coming for 1 second alternatively. So when I close the switch, you can see now all the LEDs are being in on state and all the LEDs are going to off state with a time interval of 1 second. So until my switch is pressed, this status will continue. So if I release the switch, again it will go back to the earlier status. It is 0x55 and 0xAA. So this is how we control the LEDs through the status of your switch. Thanks for watching. Please subscribe for more technical learning. Thank you.